Hi all, I'm Nivas again. Uh, let us do a problem which is a little bit more difficult than what we have done earlier. Okay, a weight B with mass 10 kilogram is fastened to a rope as shown in the figure. The distance AB is constant. So here, this is the weight B. It has 10 kilogram. The distance AB is constant, that is AB. This distance is constant. How heavy weight P is it necessary to choose for alpha is equal to 45 degree, beta equal to 65 degree? So we have a weight here on a pulley P. So we have to find the weight P such that this angle alpha and beta should be 45 and 60. And also, how big will be the stress in the rope AB in this case? That is, in this part. How will be how much will be the stress on this part of the rope? So this is a really a nice problem. So first what we will do is, first we will do the FBD, that is free body diagram of this problem. Let us do the free body diagram of this problem. Okay, so now we need to represent it in vectorial form. So let us represent the forces acting on each blocks, and let us represent all the forces acting in this rope as well. First, let us consider the weight P. Yeah, on P we know that there will be a force acting downwards, right? That is weight of the P. Let us call it as force G P. Okay, that is weight of the P. And there will be a force that we are using to pull this P up, right? That we call it as FP. That is the force which is pulling the, keeping the system in stability. So this force is acting upwards. Okay. So these are the two forces acting on P. Now let us look into the point B. So we have a weight, let's call it small b, weight acting downwards. So what are the forces here? Of course, we have a weight of this B. Let us call it as F G B. Okay, it's the weight downwards. Now we have forces upwards, which are keeping the weight in stable condition. So there is two forces here. One is the force P. Here we have a condition is given, is that given we have a condition here, the distance AB is constant. That means this is not changing. So that means the system is in equilibrium. So the force with which we are pulling the system up, the P up, will be the same force acting on here, but in opposite direction, right? So the pulley is here to change the direction of force. So the force FP is in this direction, and the force, let us call the force by which this support or this frame is pulling this system upwards. Let us call it as force A. So we have all the forces represented here. Okay. Now let us consider P. On P, let us draw the free body diagram. On P, let us consider the point P. Here we have F G, the equation of motion F G P minus FP will be 0, right? Because they are in opposite direction. And FGP, we know that we can write it as mass of P times G is equal to FP. Mass of time P is equal to, this is the condition here. Let us look on B. So in case of B, the weight here, we have the force acting downwards. We know that FGB is, what is it? It's the weight, right? So that is MB times G is the weight acting downwards. And what is the definition of force? FP. FP is the force with which we are pulling the weight P up, or we are supporting the weight B by pulling up. Okay, it is the force FP, force with which the rope P is pulled. Similarly, FA is the force with which the rope is tied to the wall. Okay, the wall is pulling up this weight using the force Fa. So now we need to solve these equations. Okay, we will solve these equations and we will find the weight P, and we will find the stress on this part. Okay, let us get back. Let us erase these things. And we will write on P part, the equation of motion for P part, that we have already written. FGP, force GP is equal to FP. Okay, let us call this as equation number 1. And for B, in the case of B, we have FGB, we can write it as FGB plus FA plus FP is equal to 0, right? Because the system is not moving, the system is stable, so the resultant force is 0. So FB plus FP plus FA is equal to 0. Let us call this as equation number 2. Now we need to solve for these forces, right? So let us look at the x-axis. Let us look just the sine components of these forces. Okay, so we know that in x-axis this is acting in this direction, and this force Fa is acting in this direction in case of x-axis, right? So we can write it as Fp sine beta is sine beta minus, because Fa is in the opposite direction, right? Fa sine alpha is equal to 0, right? So Fp minus Fa in the x direction is equal to 0. That means, or let us write it as equation number 3. In the case of y-axis, what will be the equation? Can you guess it? So we have written for x-axis. Now we have to write for y-axis. In case of y-axis, fa cos alpha. This is cosine component of force. Fa cos alpha plus fp cos beta is also cosine component of fp minus, because in y-axis both these forces are upwards, they are in positive direction, and fgb is in negative direction, right? Minus fgb will be 0. It's again 0 because the system is stable, the system is not moving. Let us call this equation number 4. Okay, now we have written 4 equations. Let us clear this part. Let us clear this part. Okay, we have cleared it. So from equation 3 we can calculate fa, right? If we simplify equation number 3, what we will get is fp sin beta is equal to fa sin alpha. That will be the simplified model. From this we can calculate fa is equal to fp times sin beta divided by sin alpha. So this is our equation number 5. Okay, so now we have 5 equations. Now let us substitute this equation 5 on equation 4. Let us substitute 5 on 4. So substituting 5 in 4, what we will get is, substituting for fp, so what we will get is fa cos alpha plus sorry, we are substituting for fa, so fp times sin beta by sin alpha times cos alpha plus fp cos beta is equal to fgb. Now let us take a common denominator here, so we can write it, we can take out fp and sin beta cos alpha plus cos beta sin alpha, right? So this sin alpha we will multiply here, and let us take it as common denominator, and let us take this sin alpha into the right side. fp will be is equal to fgb times sin alpha. Now we know that sin beta cos alpha plus cos beta sin alpha is what is, it is sin alpha plus beta, right? So fp times sin alpha plus beta is equal to fgb sin alpha, and we need to find fp here, right? So let us clear the right hand side. Let us clear the right hand side. So we will substitute for we will find FP. That is what we need to find here. So FP is equal to FGB sine alpha divided by sine alpha plus beta. Actually, it's alpha plus beta. FP is equal to FGB sine alpha divided by sine alpha plus. Let us call this equation number 6. And we know FP, right? FP is MP times G is equal to FGB is mass of B times G times sine alpha divided by sine alpha plus beta. Here we have G in common. Let us cancel out G. So we will get MP is equal to MB times sine alpha divided by sine alpha plus beta. Let us call this as equation number 7. And we can substitute the equation 6 in equation 5. Okay, so we have FA is equal to FP sine beta by sine alpha. Here FP is FGB sine alpha by sine. So let us substitute this FP here. Let us clear here these equations. So what we will get is FA. We will get the equation for the force with which the rope is tied to the wall, FA. So FA is equal to FP is FGB times sine alpha divided by sine alpha plus beta into this part sine beta by sine alpha. But we have sine alpha here, sine alpha. This will be cancelled. So FA will be equal to FA, the force with which the rope is tied to the wall, is equal to FGB sine beta divided by sine alpha plus beta. That will be our FL. So now we have all the equations, right? We need to find the mass P. So we have equation for mass P, and we have equation for the force with which the rope is tied to the wall. So we just need to substitute the values. What is the value we need to substitute? Let us look into the question. We have MB is mass of B is 10 kilogram. Okay, so mass of B is 10 kilogram and the angles alpha is 45 degree and beta is 60 degree. So let us substitute it. MB is equal to 10 kilogram, alpha equal to 45 degrees, beta equal to 60 degrees. Let us substitute in equation 7. What we will get is mass of P is equal to MB is 10 times sine 45 divided by sine 45 plus 60. So if you substitute the values for sine 45 and sine 60, MP will be, we will get the mass of the MP as 7.3 kilogram. Okay, now so we have the mass for P is 7.5 kilogram. Now we need to find the force. The force with which the B is tied to the wall A. That is Fa, the force Fa. We substitute FGB. FGB is equal to, let us consider G as 10. So mass of P is 10 and G as 10. 10 times 10 sine 60 divided by sine 45 plus 60. If you calculate it, you will get it as 90 Newton. So the force acting on, the force with which the rope is tied to the wall is 90 Newton. So we have found the mass of P as 7.3 kilogram and the force with which the rope is tied to the wall as 90 Newton. So this is the condition for stable B. Okay, so we have done our problem. Okay, thank you.